Okay, so chapter 8 is hypothesis testing, and today I'm going to talk about section 8.3, testing a claim about a mean. So some of the things you should know about this, when you do the problem from this section, you can test a claim when standard deviation for the population is not known, and in some time, very rare case, sometimes standard deviation of the population is known. So today we're going to focus on the problem when the standard deviation is not known. Okay, and remember, when we try to test a claim, this is our objective: use a formal hypothesis test to test a claim about the population mean. And these are the symbol we are going to use: sample size, sample mean, sample standard deviation, and then population mean. And these are the two requirements you must have to use this testing claim. The sample is from simple random sample. Sample should be simple random sample. And second is, either uh, you know uh, the population is normally distributed, or the sample size should be greater than 30. If you have both true, then that's good, but at least we need one of them to be true. So this is the formula you should know for finding the t-value, which is sample mean minus population mean divided by standard deviation for the sample divided by square root of sample size. And we can find the p-value by using technology here. I'm going to show you how to use a TI 8384 calculator to calculate the p-value. And to calculate the p-value using the technology, we are going to use function TCDF function, which is students t cumulative distribution function that gives you the p-value. And this function TCDF takes three inputs. You have to give lower t-value, upper t-value, and df, which is degree of freedom, which is actually degree of freedom is sample size minus 1. So in any case, there are, in any problem, when you try to use this TCDF, there are two scenarios. One is if t-value is negative, then we're going to use lower t-value as very small number, which is we're supposed to use negative infinity, but infinity is not available in our calculator, so we use negative 1 million. Similarly, in case of t positive, the upper t value here, you can see the upper t value position, we use very huge number, since we don't have infinity available, so I'm going to use 1 million. Okay, so by using this formula, by using this function in this calculator, we can calculate p-value. Remember, after finding the p-value, if p-value is less than or equal to significance level alpha, then we should reject the null hypothesis. Otherwise, fail to reject the null hypothesis, and then in that way we can make our conclusion. So look at let's try to solve some of the problem from homework here. So homework problem, let's see, this is problem number 3. What is that? Problem number 3 from question number 3 from section 8.3. The claim is that weight of quarters made after 1964 have a mean equal to 5.67 gram as required by mint specification. So that's the claim. The sample size is 32, and then test statistic t-value is negative 2.887. Use technology to find the p-value. Based on the result, what is the final conclusion? Use a significance level of 0.01. So whenever we do this hypothesis test, the null hypothesis is the average value equal to the value given here, which is 5.67. And alternating hypothesis is, in this case, we the alternate means the alternate of equal, which is not equal 5.67. So that's the hypothesis. And the test statistics here is given negative 2.887. If you round it to the 2 decimal place, that would be negative 2.89. It says rounded to the 2 decimal place. Finally, we have to find the p-value. The p-value can be found, as I mentioned earlier here, by using this formula TCDF in our calculator. You can find the TCDF by going here, use second. First on your calculator, use second and variance. So that gives you the distribution, okay? And if you do that, number 5 is TCDF function. Number 5 is TCDF. As I mentioned here, TCDF takes 3 input: lower t-value, upper t-value, and degree of freedom. In case of negative t-value here, the lower t-value is negative 1 million. That's what I am using here. You could use very small number here, like negative 2 million or 3 million, but I'm just using 1 million is fine, okay? And now the upper t-value would be negative 2.89, negative 2.89, comma the degree of freedom, because the value of n is 32, the degree of freedom is 32 minus 1 is 31, and that gives the p-value. But this p-value is only for one side of there are 3 different scenario. One is a right tail, left tail, and then 2 tail. This only gives you the 1 tail, okay, right tail. So if it's not equal, that means we're talking about the 2 tail. To get the 2 tail, we just have to multiply this p-value by 2. So times this answer by 2, that will give us our answer, and we need to round it to the 3 decimal place, so that would be 0.007. 0.007. Okay, so now if you go here and then look at this the p-value thing, it says, hey, if your p-value is less than or equal to significance level, in this case that's true because significance level is 0.01 and this is less than, so reject the null hypothesis. So based on the p-value, there is sufficient evidence at a significance level of 0.02 to rejection of the claim that weight of quarter made after 1964 have a mean equal to 5.67 as required by the mean specification. Okay, that's number 3. I'm going to choose another problem. Let's say number 7. Very similar problem. You need to find out the null hypothesis, alternate hypothesis. If you read the problem, you have given some information. The blood pressure level 120, systolic blood pressure levels above 120. So as we know that more than 120 blood pressure level considered to be high. For the 100 systolic blood pressure level, so that means this is the sample, 100 sample. If you click here, it gives you those data, the sample data. For this 100 sample data, the average the mean blood pressure is 121.36, and the standard deviation is 14.41907. So you can calculate this standard deviation and mean by using this data, but it's already calculated here. Assume that a random sample has been selected, simple random sample has been selected. Use a 0.1 significance level to test the claim that the sample is from population with the mean greater than 120. So that's the that's the claim. We are claiming that the sample is taken from the population where the mean is greater than 120. That claim would be true if the p-value is greater than 0.1. So let's try that one. Here in this case, the mean average is equal to, always the null hypothesis would be equal to 120. That's the the null hypothesis. And then alternate hypothesis is greater than 120. So what we're saying is this sample is taken from the population where this mean is greater than 120. So now find the t-value. This means to find the t-value, and for finding the t-value we have the formula here. This is the formula we're going to use for the t-value. T equal sample average minus mean average over standard deviation for the sample divided by square root of n. So in this case, you can see that the sample average is 121.36, and population average, we are going to always take this as a population average, 120 over the population no sample standard deviation is 14.41907 divided by square root of n. N is the sample size 100, so square root of n means square root of 100, which is 10. So if you just use your calculator, which is type let me just clear this 121.36 minus 120 divided by 14 point what is that, 41907 divided by square root of n, which is 10 in this case, parenthesis close, and then hit enter. That is our t value, which is 0.94. If you round it to the 2 decimal place, it's a 0.94. Okay, that's our t value. Now based on this t value, we can calculate the p value. As we know already, the p value can be calculated by using the TCDF function in our calculator and that function takes lower t value, upper t value, and then degree of freedom. In case of positive t value, the upper t value would be positive 1 million, lower t value would be the given value you have here. So to get that TCDF distribution, we have to go to the second and variance. Here you see the distribution, go to the number 5, that is TCDF. So lower t value in this case is 0.94, upper t value is that 1 million I'm taking. It's not 1 million, you can choose any huge number. I'm taking 1 million, comma, degree of freedom in our case is 99. So that gives us the p-value, which is 0.1747. If you round it to the 3 decimal place, it would be 0.175. 0.175. Since this p-value is greater than this significance level, so let's go here and check if the p-value is greater than the significance level, then what is that? If the p-value is less than or equal to the significance level, then reject the null hypothesis. But in our case, it's a greater than, so fail to reject the null hypothesis. There is sufficient evidence at the 0.10 significance level to support the claim that sample is from a population with a mean systolic blood pressure level greater than 120 mg. Oh yeah, wait, what did I do wrong? Fail to reject. So we fail to reject the null hypothesis. There is not sufficient evidence at the 0.1 significance level to support the claim. Yes. Okay, so there is not actually, because the p-value, if p-value is greater than 0.175, if it fails, then there is not. If it's not fail, then there is. Okay, so these are the only two options you have available. So let's do one more problem. Let's say problem number 11. Listed below are the lead concentration measured in different Ayurveda medicine. Ayurveda is a traditional medical system commonly used in India. The lead concentration listed here are from medicine manufactured in the United States. Assume that a simple random sample has been selected. Use a 0.1 significance level to test the claim that the mean lead concentration for all such medicine is less than 40. So as usual, the mean is equal 14, and then the alternate hypothesis is less than 14. So this is our hypothesis. Now we need to find out the t value one more time. For finding the t value, you need to find what is that? there is a formula for finding the t-value. What is the formula? The formula is this one: average, sample average, population average, standard deviation, and square root of n. In this case, you don't have given those value like before, so but you can calculate this value because the sample size is very small. You can do that. So you need to find out the mean. You need to find out the the what is that called, standard deviation. And this is the population mean is already given, that is 40. So you need to find out the sample mean and then sample standard deviation. These are the two things, and you can use the calculator for finding those value. So I'm going to use stat and I'm going to use the data here. The data here is 3.0 3.04. I'm going to use this data 6.46 5.96 5.52 20.49 and 7.46 7.46 12.04 20.50 20.5 and 11.48. You already know how to find the standard deviation. There is a standard formula, but you can use your calculator for finding that by loading your data here. So as you can see, that's 17.53 11.48 20.5 12.04. Okay. So now this is our data, and now we go to the stat and we go to calc here. And if you go to the number one, which is the one variable statistics, so it's equal here, and then if you just enter that, it will give you the value, all the values you are looking for that data. That data means the data we just input. So average is 11.048 and standard deviation is 6.46. Okay, so that's the sample standard deviation. Now I'm going to use this average and sample standard deviation here for calculating the t-value. So what is the t-value? T-value is sample mean minus population mean divided by sample standard deviation is square root of n. In our case, sample mean, as you can see here, what is that? It's 11.048 minus the population mean is this one 14. You always take this one as a population mean, divided by the sample standard deviation is this one 6.465 divided by square root of n, which is in our case square root of 10. Make sense? So by using this we can calculate what is that called, the t-value. So let's do that here. Let me just clear this and then just type this value here, 11.048 minus 1,414 divide by parenthesis 6.465 divide by square root. As you can see, that second and this one is the square root 10. That's our sample size. Another parenthesis close, and that gives me negative 1.4439. Round to the two decimal place, that means it's a negative 1.44. So that's a t-value. So we can calculate this t-value by using the data we have given here. So by using this t-value, now we need to find out the p-value. So again, for finding the p-value, we go to second and this variance, which is the distribution number 5, and because it's a negative, so lower t-value is negative 1 million. That's what we take, 3 zeros. Upper t-value is negative 1.44. Did I put the negative here? Yes. And comma, degree of freedom is 9 because the sample size is 10. So that gives us 0.091. round to the 3 decimal place, it's 0.092. 0.092. Great. So as you can see here, this p-value is less than the significance level. So as we go here like before, as you can see, if p-value is less, what is that? No, yes, this one. If the p-value is less than or equal to the significance level, reject the null hypothesis. So reject the null hypothesis. There is, if you reject, there is sufficient evidence to support the hypothesis. That's all.